Hi there. My name is Jose Alferrica. I'm a developer relations engineer working on Android.
My name is Zied Boyer. I also work on the Android team.
And today we're going to talk about live data again. We were here last year with a talk titled Fun with Live Data. Today we're going to talk about its integration with coroutines and with Flow. So since API, we've struggled to understand Android's life cycles. We've all studied the diagrams and more diagrams, and then fragments came along and generated more diagrams. So, we Android developers tried to isolate ourselves from having to deal with this problem. We created a layer architecture in which only the presentation layer would know about the life cycle. And then even inside the presentation layer, we found some patterns and some rules that work well, like, for example, having an object that would survive an activity or a fragment recreation. We use this idea in the ViewModel class in architecture components. So let's look at that animation a little bit more in detail. So a view is created, and a ViewModel is obtained. So it's created as well. It exposes one or multiple live data, and then the view subscribes to these live data via data binding or manual subscription. Then there's a configuration change, a rotation, for example. The view is destroyed, and a new instance of the view appears. It subscribes again to the live data, and the view model doesn't know what just happened. The view model doesn't even have a reference to the view, it just exposes data. So why are we talking about this? Whenever you do an operation, and an operation can be something like fetching data from the network, preparing some text, you have to choose the scope of this operation. This means when this operation is going to cancel. If you cancel too late, then you might be wasting the user resources. If you cancel it too soon, you might have to restart your operation. But in a real-world app, and this is the Android Dev Summit app, we have way more scopes than that. For example, we have a schedule screen with potentially multiple instances of the fragment schedule, the view model that is scoped to the screen, the agenda, the info screen with fragments and view model as well. Then we have a main activity and a view model that is scoped to this activity. And then you can even have custom scopes. With the navigation component, for example, you can create a scope for a login flow or for a checkout flow. And then we even have the application scope, which is a special case we'll talk about later. So there's going to be a lot of operations happening at the same time, and we have to manage the cancellation somehow. We need a way to find something that helps us structure this concurrency.
What would that be? That's, of course, our new best friend, Kotlin Coroutines. Now, we don't want to go through and make an introduction to Kotlin Coroutines, but we want to talk about why we like it for this particular use case of Android development. Briefly, there are like three main nice things. First one is it's very easy to get off the main thread. Like, this is a problem we tried to solve with like 20 different technologies, albeit. With Coroutines, you just launch it, and then you can change your dispatcher. It's very easy to write. And while writing that, you don't need to write boilerplate code. This is probably the best thing about Kotlin Coroutines. You write it as if you're writing like blocking code, and then it's all compiler magic and becomes asynchronous. But these two are nice properties, but they're not the reasons why we like Coroutines for this case. The main reason is the structured concurrency it provides. It's a little bit complicated, but basically you can consider structured concurrency as a garbage collector for your jobs. So when something doesn't need to run anymore, it is killed for you automatically. And this is why we like it. So if you like coroutines on Android, how do you launch them? Luckily, in the Jetpack components, we provide scopes for related Android components. So for example, if you're in a view model and you want to run something in the scope of a view model, there's a view model scope. You could use it to launch your coroutines. Or if you're in an activity or a fragment, you can use the lifecycle scope, which gets canceled if the lifecycle is destroyed. Now, in this lifecycle case, there's one more thing. Sometimes you want to run certain operations when the lifecycle is started, like a fragment transaction. For those cases, you can use this launch when started, resumed, or created methods. What this does is it runs your suspend block only when the lifecycle is in the desired state or greater. And if it, let's say you said launch when started and the activity stopped, we suspend that computation until the activity resumes. Now the third layer is your application layer where things get a little bit more trickier. Like assume you want to run something that's not tied to any screen. In those cases, you need to figure out whether you should be using Work Manager or not. And the question you ask is, does this thing has to complete? Like if you're writing a Twitter client and you need to send it to your server, please use Work Manager because if you lose that tweet, that will be a shame. But if you're trying to do something where you're going to clean the local database, it's fine. You can use the application scope. Like if that doesn't complete, it's not the end of the world. You can do it next time the application starts. Now let's look at how we can use that view model scope with a live data. Here we have a common pattern where you have a private mutable live data that you provide as a public property to do your UI. Inside here, we launch our view model scope. We do some suspending computation. And when the result comes, we update our private mutable live data. And notice that I'm just setting the value there. I'm not calling post value because this runs on the main dispatcher by default. Since Lifecycles 2.2, there's a much nicer way to do that pattern, which is a new builder called live data. This live data builder gives you a coroutine block, which is like a scope for your live data. It starts executing when the live data is observed and canceled when the live data is not used anymore. And inside there, you can emit. Another very common pattern is like imagine you have a UI where like user selects some item and then you display the contents of that. A very common way to do is that you keep that item ID in a mutable live data, run a switch map transformation on it. And again, for those cases, you can use this live data builder and just do a coroutine computation. This live data builder also receives a coroutine context, so you can tell it to maybe run on the I/O by default. And it doesn't matter, you can still call emit, so you don't need to think about which thread or which dispatcher I'm on. You can always call emit. There's one more function called emit source, which receives a live data. This basically says, whatever these other live data dispatches, send them as my value. So how do we cancel them?
All right. So how do you cancel a coroutine? Well, I'm not here to talk about how to actually cancel a coroutine that you just started. We've been talking about scoping our coroutines so that this is done automatically for us. There's some use cases for this, but normally you won't be canceling your own jobs. What I want to point out here is what happens if you are designing a suspend function, and that function, for example, has an infinite loop. How does Kotlin know when to stop that loop? Well, it turns out there's a little bit of magic here. All suspending functions in Kotlin X coroutines are cancelable, and delay is one of them. So when delay is called, it's going to check if the coroutine is canceled, and if it is, it's going to stop the execution. So what happens if you're not calling any cancelable functions in your suspend function? Well, you have to cooperate. We say that cancellation is cooperative. You have to check if the coroutine is active regularly with the isActive property. So before we see some patterns, there's an important distinction that we have to make, and that's between one-shot operations and operations that are going to return multiple values over time, and we're going to see this with an example from the Twitter app. So in order to load the data needed for this screen, you have to perform some one-shot operations. Downloading the profile picture, the Twitter handle, the tweet itself, because tweets are not editable in 2019. Mike? But there's another thing. There's an interesting thing at the bottom, number of retweets and number of likes. This UI is observing a data source, because if you keep this screen open, those numbers are going to change over time. So that's the difference. So how does a one-shot operation look like in the big picture? We use live data between view and view model for the reasons that I explained in the introduction. And then in the view model, we're going to make this bridge between the live data world and the coroutines world using the live data coroutine builder. Super easy in the repository because we are in suspend functions. We can just call suspend functions in the data source. We get the result. We're done. When we have to deal with multiple values, things get complicated. And we can solve this with live data. We can use live data beyond the view model, and our talk last year was partly about this. But live data was never designed as a fully fledged reactive streams builder. So it's a little bit awkward to use. So luckily, there's a new API called Flow. Flow is part of Kotlin coroutines. And we're going to see some examples of some code examples, and we're going to look at view model, repository, and data source. So first, we're going to see some view model patterns. We're going to compare two view models side by side. One is going to subscribe to a live data or consume data from a live data, and the other one is going to consume from a flow. So the first pattern is about emitting multiple values. If we're not doing any transformations to the values, then we can just assign a live data that we're observing to the live data that we're exposing. That's very easy. In the case of flow, we need to convert from a flow to live data somehow. So we could use the live data coroutine builder. So we collect each item from the flow. That's how you consume a flow. And then we emit to the live data coroutine builder every item. Now, this is more or less readable, but if you have to do this 15 times in your view model, it's going to be a lot of boilerplate. So we created this handy as live data extension function that is going to convert any flow to live data, and we're going to use it in the rest of the examples. The next pattern is emitting one initial value and then emitting multiple ones. So we already saw this pattern. We use emit and emit source from the live data coroutine builder. In Flow, we could use the same pattern. We pass the flow converted to live data with as live data. But this is not very readable, and well, it's super awkward, and we're creating a live data twice. So it's much better if we embrace Flow's API, and we use this thing called onStart that is going to let us define what the initial value of that flow is. And then at the end, we just convert to live data. And this is where Flow really shines. Normally, you want to do a transformation on each item that you are observing or that you are receiving. If we do this with live data, then you might want to try map first, but this would be main thread, and it would be awkward to use a coroutine from here. So it's much better that we use switch map, and we return live data created with the builder, and because we are in a coroutine context, we can call this heavy transformation function, which would be a suspend function, and emit its result. With Flow, this is much, much better. We just call map on the flow. And because we are in a coroutine context, we can call the suspend function. And at the end, we just convert to live data.
All right, so how do we use the suspend functions and Flow library in our repositories? Now, repositories usually where you have a lot of custom code, like you're making APIs, collecting data, filtering, whatever business logic you have. In these cases, you may want to do a lot of transformations. And as Jose mentioned, like we never intended live data to do these things. Luckily, with Flow, you have all these operators on your streams that you can use. So just go ahead and use Flow or suspend functions in repositories. Similarly, for your data sources, suspend functions and Flow are great fit. But here, things get a little bit more trickier because this is usually the part of your code where you're talking to other libraries, remote sources, whatnot, so you don't control all of it. So let's look at all those cases, see how we can integrate them. The first case, the best case, is you have one-shot operation. So you have one-shot operation to get some value, like let's say from a network request. So if you're using retrofit, just mark the function as suspend, and you're done. Retrofit already supports suspend functions since version 2.6. Similarly, if you're using Room for your database, since version 2.1, it supports suspend functions. So you tell it to return a suspend function, done. You don't need to care about it anymore. But if you're dealing with a library that's not updated for the coroutines world, maybe it's a Java library and it has callbacks, sounds super old, callbacks, now you need to do some work. For those cases, we have this thing called suspend cancel work coroutine builder. This thing is basically the adapter between the coroutines world and the callback-based world. What you do is when you call this function, it gives you a continuation that you are responsible to call. So we make our API request. If the API gives us a value, we resume the continuation. Or if the API tells that an error happened, we resume the continuation with an exception. This is all you have to do. Once you do this, rest of the coroutine machinery works, and you can abstract this somewhere outside of your code. Notice that if you happen to call this continuation much later, like after it's canceled, it's just ignored. And you can also change this code a little bit better so that if the coroutine is canceled, you can eagerly cancel your API request. Now, the third case is where you have a lot of values, like you want to emit multiple values. And Flow Builder is a great thing. It's very similar to the Live Data Builder, except you build a flow, and you can emit values. So we have an example here that like infinitely every 2 seconds dispatches a new weather value. It's also super handy when you're writing tests, actually. You just like say, oh, this is this other flow. But if you are working with an old library again that doesn't support flow and is a callback, you can use this callback flow builder. It's very similar to the previous one we saw. So let's say we have an imaginary API here that receives an imaginary callback, and that callback has 3 functions. It's like next value, on error, and on completed. We register that callback with our imaginary API, and every time we receive one of those callbacks, we just say, OK, offer that value. If a new value came, offer it to the flow. Or an error happened, basically close the flow with this error. Or if it closes nicely, same way, close the flow. Now, you need to be careful here, because this callback flow builder, once it returns, flow is closed, so you cannot dispatch values to it anymore. We don't want it to return. So for those cases, we have this function called await close, which basically suspends until the flow is not collected anymore. There might be any reason you close it here, or maybe the collector just stopped collecting. And in that case, we simply unregister from our API. Now, testing. So we would like to talk about testing, but we don't have that much time. No. Test. No, we have time. Testing is important, so we have a full-fledged talk on testing by Sean and Manu tomorrow at 5:15. Please go watch the thing to see how you can effectively use coroutines in your tests. Before we leave, there is one more thing. With the introduction of Flow and the lifecycle scopes we have shown, you can actually get the benefits of live data without using live data. So if you could be doing this, where you say lifecycle scope, launch when started, and start collecting on this flow. This will behave exactly the same way a live data behaves for your UI. Now, it's not 100% the same thing, because live data has this caching behavior. But it's close to there. So this is something you may want to consider. And for any questions, we'll be upstairs for the Q&A. Thank you.